In this video, I will continue talking about the multiples and lowest common multiples. The video will cover R1, R2, and P1. Let's read the question. Bob says the lowest common multiple of 4 and 8 is 32. Is he correct? Let's start by solving the question ourselves. The lowest common multiple of 4 and 8, we can find it by listing the multiples of 4, 8, 12. Let's list the multiples of 8 as well. The very first number I list is 8. So I immediately found it. The lowest common multiple of 4 and 8 is 8 itself. So let's now focus on our questions. The mistake that Bob made was that he just went ahead and multiplied the two numbers instead of listing the multiples and finding the actual lowest common multiple. So the mistake that he made is he did not list the multiples. The correct answer is, as we have worked out above, 8. The misconception was that he did not know how to calculate the lowest common multiple of 4 and 8. He just thought you need to multiply them together. So his misconception was not knowing how to calculate LCM. He thought it's just multiplication. Moving on to R2. Liz says that 6 is a multiple of 18. Is she correct? Now, at the first look, we might think that she is correct. But if we read the question carefully, we'll figure out her mistake. Liz says that 6 is a multiple of 18. Is that correct? No, it is not. Because in fact, 18 is a multiple of 6. Remember, multiple means multiplying a number by natural numbers to get a number. So we can say that 3 times 6 is 18. Therefore, 18 is a multiple of 6. If we want to answer the question, we can say that no, she is not correct because it is the other way around. 18 is a multiple of 6. Remember to always check if the question says it correctly. It is always the bigger number, which is a multiple of the smaller number, or equal, and not the other way. I will now work through a P1 type problem. Let's read the question. Pam is at the Dover ferry port. She notices that the ferry to Calais leaves every 3 hours, and the ferry to Dunkirk leaves every 4 hours. A ferry to Calais and the ferry to Dunkirk leaves at 3 a.m. Question 1 is, how long will you have to wait to see both ferries leave together? We can first start with the Calais ferry. We know that it left now at 3 a.m. We know that it left after 3 hours, so that will be after 3 hours. It will be leaving after another 3 hours because it leaves every 3 hours. That's after 6 hours together now. And another 3 hours it will leave. And another 3 hours it will leave. And so on. So every 3 hours it leaves from the Dover ferry port. We can see that these numbers are the multiples of 3. These are how long from now the Calais ferry will leave. Now if we do the same for the Dunkirk ferry, it again starts from 3 a.m. but it leaves after every 4 hours. So the first time it leaves is after 4 hours, and then another 4 hours, which will be after 8, and then another 4 hours. So altogether after 12 hours. And we can see that these are the multiples of 4. So when the first question asks, how long will you have to wait to see both ferries leave together again? The answer is 12, which is the lowest common multiple of 3 and 4. This is how long you have to wait to see the two ferries leave together. That's not at what time they will leave, it's how long you have to wait. So the second question is asking us, at what time do both ferries leave together again? Now in the first question we calculated that we'll have to wait 12 hours for them to leave together again. That means that if we know that they leave together at 3 in the morning, and we'll wait the 12 hours to see them leave together again. Then 3 plus 12 is 15, so they will leave together again at 15 hours or 3 p.m. in the afternoon. And that is the answer to the second question. So notice the difference between the first and the second question. The first is asking you the duration. How long will you have to wait? That's when you use lowest common multiples. The second question is asking you at what time do both fairies leave again, and for that you need to know when did they leave together in the first place, and add to it the duration you have to wait, and that will give you when they leave together again.